All right, here we go with homework 4-3. I use Venn diagrams a lot to help me understand probability. So I'll be drawing a lot of these, but in this case, you're forced to kind of look at one to help you get an understanding of what they call the addition rule for probability. So here we go. It says that event A is students in the dance club. We have 10 students, and we have to find down here, what's the probability that the student is in the dance club. So if I look at the dance club, just this circle right here, those are the members of the dance club. And it looks like there are 6 of them in there. So I would say 6 out of the 10 people are in the dance club. So 6 out of 10 are in the dance club. And they want me to write that as a fraction, so I can just leave it as 6/10. All right, event B, students in the science club. Okay, so down here I'm looking for the probability of students being in the science club. So if I look at the science club, these are the kids in the science club, just here in red. And there are 5 of them. So I would say, okay, well, that means 5 out of 10 people are in the science club. So down here it says, tell me the probability of being in the dance club and the science club. What's the probability of being in the dance and the science club? So we found that this was the probability of being in the dance club, and this is the probability of being in the science club. If I were to add those together right now, I have counted these guys this guy and this girl. These 2 students here got counted twice. Okay, they got counted here and they got counted here. So what I got to do to make amends for that is subtract out. We call that the intersection. This is where those 2 groups intersect. So I'm going to subtract out the intersection. I'm going to subtract out those 2 of 10 right there. And that's going to leave me with my total probability of being in one of those 2 clubs, which would end up being 9 out of 10 would be my final answer. Okay, so it's the probability when you have groups. We call these groups are independent of one another, so they have some overlap there. It's the probability of the probability of A and B. If I write it out, and it's going to look like probability of A plus the probability of B minus the intersection of those 2. And this is the symbol we use for intersection. Okay, probability of A plus the probability of B minus their intersection will tell me the probability of A and B. Or you might see it written this way, the A union B. Same thing as A and B. All right, let's go to the next one. So here we have 63 people. We have 63% of the people at a certain conference are doctors. 62% are women. 74% are doctors or women or both. What is the probability that a person selected at random at this conference is a female doctor? Okay. So I've got, let's see, like I said, sometimes a Venn diagram will help me. So I have people at a conference. So 100% of the people at this conference are going to be in here. And 63% of the people at those conferences are doctors. Okay, so here are all my doctors. Here are the doctors. 63% of the population are doctors. 62% are women. All right, so here are all my women. Now, some of those doctors are women, so I'm going to have these groups overlap. And that is 62%. All right, so it tells me that 74% of the people at this conference or doctors or women's or both. So that means in these two circles right here, this circle, so everything in here adds up to 74%. Okay? That means if I took all the doctors and added the women, that's going to be more than this 74% over here. It's going to be way more. How much is it going to be? If I added those together, I got 1.25, I believe. Okay, so there's a huge overlap here. There's a lot of stuff going on. There's a big overlap among these because this is supposed to be 0.74. So to find out what this overlap is, I'm gonna subtract out that 74, do a little quick math there, and that means this intersection right here has to be 51%. Let me try that again. .51 for that intersection. All right, so what that means now, I can go answer the question once I get all that information. It says, what is the probability that a person selected at random at this conference is a female doctor? Is a female doctor. All right, so the probability of being a female doctor is this overlap right here. Probability of being a female doctor is 51% of the individuals are female doctors. See if we got another one similar to that next. Not do though. Let's go back to this. At Frank's Auto Plaza, there are 15 new cars, 7 used, 9 new trucks, and 6 used. Frank is going to choose one of these vehicles at random to be deal of the month. What is the probability that the vehicle Frank chooses is new or a car? All right, so let's find out how many total we got here. 15. I'm counting 37 total in his inventory. And the ones we're concerned about are cars. So here's a car, here's a car, or new. New truck, and this is a new car, which we've already counted. So I've got these numbers here, 15, 22, that's 31. So I've got 31 either cars or new items out of this 37. Boom, type it in my calculator, give me 2 decimals, plug it in, should be golden. All right, good luck with these. Let me know if I can help you. Adios. Let's see. Let's try this one. This is kind of similar. Again, I'm going to draw myself some Venn diagrams. It says 42% of the people at a certain conference are doctors, 38% are women, 51% are doctors or women. What is the probability? So it's very similar, just the numbers are changed. Okay, so this would be a good opportunity to test yourself, maybe, and turn this off and just see if you can work this problem, and then see if you get the same thing I get. But let's see, here are the people, all the conferences at all the doctors and women at my conference. Here are the 42% of the doctors. So here are the doctors, and they make up 42% of the people here. And here are the women, and they make up 38% of the women people here. And it says these two circles add up. Everybody in these two circles add up to 51%. But right now, if I did the math, took the doctors and took the women and added them together, I get 80%, not 51%. Okay, so if I do some subtraction here, that means there's a 29% overlap there, okay? 29% of the, there are 29% of the population are women doctors, okay? And I think that's what it asked me for. What is the probability that a person selected at random at this conference is a female doctor? Boom, that intersection right there, 0.29. All right, let's try another one. I think we got a different type of problem. There's one I did in this next one. Let's see here, it says, Mr. Jenkins is about to give one of his students a piece of candy for asking a good question in class. He is going to choose the piece of candy at random out of a bag he brings to class. The following pieces of candy are in the bag: 15 apple gumballs, 4 grape gumballs, 9 apple suckers, 3 grape suckers. What is the probability that the piece of candy Mr. Jenkins chooses is grape or a sucker? All right, so let's find out. First thing we want to do is find out how much candy we got here. We got 15 gumballs. We got 15 apple gumballs. Let's try that again. We got 15 apple gum. We got 4 grape gum. We have 9 apple suckers and 3 grape suckers. So that's a total of 19, 28, 31 pieces of candy. Yeah, 31 pieces of candy, okay? And we're asked, what is the probability that the piece of candy Mr. Jenkins chooses is grape, or a sucker? So this would count too, right? Grape, and then this was a sucker, and this was a sucker. So out of all of those, that was 4, 9, and 3, it's 13, 16 out of these 31 are either grape or a sucker. So I would type that in my calculator, round it to wherever they say round it to, type it in, should get the answer right. Moving on. Same kind of thing, Mr. Jenkins again. Is this the same one? It is the same one, all right. Well, if you want to do it again, do it again.